Episode 1 was all architecture. No nodes, no canvas, no demo. That changed today. We are going to build a Slack bot backed by a React agent with persistent Redis memory and 3 live tools. By the end of this episode, you will have a working agent that remembers your users across sessions, knows how to search the web, look up CRM contacts, and draft emails, with a human approval gate before anything sends. Every workflow we build is exported to GitHub as importable JSON. You do not have to follow along live. Just clone the repo, import the files, and the agent runs in your own n8n instance. Let us start with the problem this episode solves. Why does memory matter so much, more than the most tutorials suggest? Here is the uncomfortable truth about most AI chatbot integrations you see in tutorials. The agent answers your question, then forgets you completely. You come back the next day or even later in the same Slack workspace, and it has no idea who you are or what you discussed. This is not an agent. This is a stateless function wrapped in a chat interface. Look at the left side of this slide. Day 1. The user asks about headphones. The bot responds. Day 3. The user says, how about something cheaper? The bot responds with cheaper than what? It has no context. The session is long gone. The right side shows what we are building. Day 3. The agent knows this user was looking at Sony VH1000 XM5 3 days ago. It knows the price point. It responds with contextually relevant alternatives. The technical reason this works is Redis. Instead of storing memory in the browser session, which vanishes the moment the connection closes, we store the conversation history in Redis key to the Slack channel and user ID. Redis persists to disk. It survives n8n restarts. It survives container redeploys. The agent picks up the conversation exactly where it left off, days or weeks later. This is the difference between building a chatbot and building an agent. Let me show you the full architecture before we start building, so you know where each piece fits. The architecture is straightforward. A Slack message comes in via trigger node. It goes to the React agent, which has Redis chat memory attached. The agent can call 3 tools: search the web, look up the CRM contact, or draft an email. The draft email tool has a wait node, a human in the loop gate, before Gmail sends it. The final response goes back to Slack. Each of the 3 tools is its own n8n sub-workflow, wrapped as a workflow tool node and connected to the agent. The agent sees them as callable tools with name, description, and a JSON input schema. It decides when to call each one based on the user message. Everything you see here is importable from the GitHub repo. Let us start with the stack setup. We have the main agent JSON, like here, tool search web JSON here, tool lookup CRM JSON here, tool draft email JSON is here. Okay, now open your terminal, and this takes about 5 minutes. We are running n8n and Redis together in Docker Compose, 2 services. The Docker Compose YAML is the GitHub repo under the episode 2 persistent agent /Docker. Here it is, n8n, image, ports, environment file, depends on Redis. The Redis image is Redis 7 Alpha. The n8n service is straightforward. The official image port 5678, and one environment variable that matters is the encryption key. n8n uses this to encrypt all credentials stored in its database. Set it to a long random string and do not lose it. The Redis service uses the alpha image, small, production, sustainable, and suitable. The important flag is append only as. This tells Redis to persist its data to disk, which is what makes memory survive container restarts. Without it, Redis in memory only, and you lose your agent's conversation history on every restart. They share a Docker network. n8n can reach Redis at the hostname Redis because that is the service name in the compose file. Run docker compose up -d, wait for both services to start, and navigate to localhost 5678. Create your n8n account on first login and you are ready to build. Let's do it. Let's open a terminal from our Visual Studio Code. Let's go inside episode 2 Docker. Let's copy environmental example to the environmental variables. So n8n encryption key must be here, open API key must be here, and Brave API key must be here. Alright, now let's Docker compose up. Docker is running. Let's open up Chrome and went to localhost 5678. That's it. Now we can go inside n8n. Alright, we set up our account and we say the credentials here. Yep. Software as a service, business owner, myself, 20 people, YouTube. Send me a free DSK. Yep, build workflow is here. Alright, now we built the main workflow and this is the orchestration layer. The Slack trigger, the agent, and the memory node. Create a new workflow, add a Slack trigger node, connect to your Slack app. You will need a Slack app with events API enabled. Subscribe to message channels, events with the web URL pointing to this n8n workflow. The Slack docs for this are linked in the description below. The trigger fires every time a message arrives in your configured channel. The output includes the message text, the channel ID, and the user ID. These last two are important for the session key. Now add a React agent node, connect to the Slack trigger to it, configure the language model. I am using Claude .NET, but any of 14 provider nodes works here. The system prompt is where you define the agent's persona, what it is, what tools it has, and any constraints on its behavior. Keep it concise and specific. Now add a Redis chat memory node. Connect it to the agent's memory input. The critical field is the session key. Set it to Slack trigger item JSON channel. This will concatenates the channel ID and user ID into a unique session key. Each Slack user in each channel gets their own memory context. The agent cannot accidentally blend conversation between users. Finally, add a Slack reply node, wire the agent output to it, configure it to reply in the thread using the thread timestamp from the trigger output. This keeps conversations clean, one thread per topic. Here's our canvas and let's go to the VS Code and see the main agent JSON. This is what we need to do. Everything is here: the Slack trigger AI agent, Redis memory, and reply to Slack tools for searching web, lookup CRM, drafting emails. Everything is here, the connections, everything. So we can import this. Import from file. We go to the episode 2. Yep, our main agent is here. Slack trigger, React agent, Redis chat memory, and reply to Slack wiring. The agent without tools is just a chatbot with memory. Let's give the ability to act. Create a new workflow. This is the search sub workflow. Add a when executed by another workflow trigger node. This is the entry point for every tool sub workflow. It receives the JSON object the agent sends when calling the tool. Add an HTTP request node pointed at Brave Search API. The URL is http API search brave.com/res-v1 web search, as I wrote it here, and at the header X subscription token with your Brave API key. Store this in n8n credentials, not as literal string. Set the query parameter Q to JSON query. This pulls the search query from the agent's tool call. Set count to 5, for instance. Add a code node after it. Transform the raw Brave API response into a clean array, like title, URL, and snippet from each result as a property. Return that array. Now go back to the main agent workflow, add a workflow tool node, set it to call the search sub workflow you just created, fill in the name, search web, fill in the description. This is the signal agent that uses to decide when to call this tool. Like search the web for current information, use when the users ask about news, prices, reviews, or anything required live data. Define the input schema, and it could be a single query string field. Connect this workflow tool node to the agent's tool input. The agent can now search the web. Let's go back to Visual Studio. Look at the tool search web JSON. We can import this to our n8n canvas. Let's go back to the canvas. Let's create new workflow, import from file, tool search web JSON. That's it. We go back to main agent. Here it is, and it's connected to a tool, and the tool is defined here. So now another tool, lookup CRM. Create another sub workflow, same as structure when executed by another workflow trigger. Then an Airtable node in the search records mode. Configure the Airtable node with your base ID and table name. In this case, the contacts table. Set it the filter formula to search by name. If you also want email lookup, add an OR condition. Add set node to clean up the return only fields agents need, like name, email, company, and last contact date. Unnecessary fields at token cost with no benefit. Back in the main workflow, new workflow tool node, name it lookup CRM. Description, look up a contact in the CRM by name or email. Use when the user mentions a person's name or ask contact details. input schema, name as a string, email as an optional string, 3 minutes of configuration. The Airtable node handles all the authentication. You are done. So let's go back to Visual Studio again. This is the lookup CRM JSON. So we can import it again to lookup CRM in a new tab. Let's import from a file. That's it. Start, Airtable search, and shape. Third tool is the most important one because it includes the pattern that makes clients trust AI agents with their communications. The email tool demonstrates the human in the loop pattern. The principle is the agent can draft and prepare anything, but it cannot send external communications without a human explicitly approving it. The sub-workflow starts the same way. The agent calls it with a to, subject, and body field. This comes from the agent's own reasoning about what the email should say, based on the conversation text. Add a Gmail node in the create draft mode. This saves the email as a draft in Gmail and returns the draft ID. Nothing is sent yet. Now add a wait node. This is the core of the HITL pattern. When execution reaches the wait node, it pauses. The execution state, everything about where the workflow is and what has happened, is saved to Postgres. The node returns resume URL, a webhook URL that when posted to resumes execution exactly from this point. The wait node has no timeout. It will wait indefinitely. The server can restart, n8n can upgrade, and execution state is still there in Postgres. After the wait node, add a Slack message node. Send a block kit message to a designated approvals channel. The draft content, the recipient, and the subject, and two buttons, approve and reject. The button actions post to the wait node resume URL with an approved true or approved false payload. After the wait node resumes, add an if node. If approved, Gmail send a draft. If rejected, Gmail delete the draft. Then send a Slack message to the agent channel explaining the rejection, so the agent knows. Back in the main workflow tool node named draft email, for example, description, draft and prepare an email for human approval before sending, use when the user asks you to send or follow up by email. In the Visual Studio, we have the tool draft email JSON here. We can easily import to the n8n canvas here in the personal new workflow. Let's use import from file, tool draft email JSON. That's it. Let me run a live query so you can see the reasoning loop in the execution log. I'm going to send a message to the Slack channel now. Find me reviews for the Sony VH10000X M5. Watch the execution log in n8n while runs. You can see the Slack trigger fires at 0 milliseconds. The React agent starts its first reasoning step. The tool reads the user wants product reviews. I should search the web for this. It decides to call search web with the query of Sony VH10000X M5 review in 2024. The search sub workflow executes under 1000 milliseconds for the Brave API to return 5 results. You can see the exact response, titles, URL snippets. Back in the agent's second reasoning step, true though, I have 5 reviews with sufficient information to synthesize an answer. It calls final answer and construct the response. Slack fires. Total elapsed about 1.2 seconds. 2 things I want you notice. First, every thought, every tool call, every tool response is visible. You are not debugging blind. If the agent called the wrong tool or misread the results, you'll see exactly where and why. Second, the total time is dominated by the Brave API call at 847 milliseconds. The n8n orchestrated overhead, the agent reasoning steps, is under 50 milliseconds combined. The performance argument against n8n only applies to very high throughput workloads. One last thing before the summary, the provider swap. I said in the episode 1 that provider abstraction is a real advantage of n8n. Let me show what that means in practice. I am going to open the React AI agent node, change the language model node from the Claude to OpenAI GPT-40 node, set the model to GPT-4, then save. That's it. The Slack trigger, the Redis memory, all 3 workflow nodes unchanged. The agent now runs on GPT-4, sends the same message. The behavior is comparable. The routing logic, the tool calls, the memory, all the same. In Python, this would mean touching your imports, your client initializations, potentially your prompt templates if they use model-specific formatting. In n8n is one drop-down change. Let's wrap it up. We built a persistent memory Slack agent with Redis, 3 workflow tool nodes, web search, CRM lookup, email drafting, and a human-in-the-loop approval gate on the email tool. Everything is in the GitHub repo as importable JSONs. Links in the description below. If you already have an n8n Redis running, import the 4 JSON files. The agent is live in under 10 minutes. Episode 3 is the cross series bridge. I am going to take the quadrant product collection from the hybrid search series and connect it against this agent as a for tool, a rack knowledge base. If you have not watched the series, there is a setup script in the GitHub branch. If you have the collection already, the workflow JSON imports runs immediately. See you in the episode 3. Don't forget to subscribe and like this video. Thank you.